Hello everyone. We have a question which says that two light inextensible strings are attached to a particle of weight 25 Newton. This is a particle, the weight is 25 Newton, and the two light inextensible string, which are this one and this one, they are attached to this particle. The string passes over two smooth fixed pulleys, and definitely we can see in the diagram that the two strings are passing over these two pulleys, and hence particle and have particles of weight a Newton and b Newton, and definitely the other end of these strings are attached to a particle whose weight are a Newton and b Newton. The sloping parts of the string make angle of 30° and 40° respectively. As we can see over here, yes, the sloping part of the strings are making an angle of 30° and 40° with the vertical, and definitely this dotted line is a vertical, and these two angles are made with this vertical side. See diagram, the system is in equilibrium, find the value of A and B. So basically the condition that they have given us is an equilibrium condition. And based on that equilibrium condition, we have to find the value of A and B. And equilibrium means the opposite forces are equal. And when we say the opposite forces are equal, that means the opposite horizontal forces are equal as well as the opposite vertical forces are equal. And for that, definitely we have to find the horizontal components and the vertical component. But before that, we should understand what the horizontal and the vertical components are. I have seen that most of the students have a misconception that the horizontal component is always a cos component, which is wrong. It is not like that. If this is an angle which is given in the diagram, then the side next to that would be a cos component of this particular force, and the opposite side would be a sine component of that particular force. But if the angle is given over here, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. That means it is not like that the horizontal component is always a cos component. It depends upon the angle, where the angle is, and based on that angle you have to decide which side is a cos component side and which side is a sine component side. If you just look at the diagram, the 25 Newton force is basically the weight of the particle as I have drawn over here, and 30°, 40°, I have splitted them up into horizontal and vertical components. So I have made two right angle triangles for 30° and 40°, and this is an A Newton force. Definitely this wire has weight as A Newton, and definitely we have to find that particular A Newton, which is the force over here attached to this string, and B Newton is the force attached to this string. So A Newton and B Newton are basically the unknown values, and 30° and 40° are given. Because this 30° is with the vertical, and so this side would be a cos component side, so this would be A cos 30 as I have mentioned over here, and the opposite would be A sin 30. Similarly, 40° is also with the vertical, so this side would be B and cos 40°, and the opposite would be B sin 40°. Now we have the horizontal component as well as we have the vertical components and this weight of the particle. The condition that was given to us in the question was an equilibrium, and that means the opposite forces are equal. So first of all, we will work out with the horizontal forces, create an condition, and then we'll work out with the vertical forces. If we just focus on the horizontal forces, we can see over here we have A sin 30, which is to the left and B sine 40 to the right. Because the condition is an equilibrium, that means A sine 30 would be equal to B sine 40 as I have written over here. Then A is equal to B sine 40 divided by sine 30, and dividing sine 40 divided by sine 30 degree would be 1.2855B. This is our equation 1, which is in terms of A and B, because we have to find the value of A and B. This was an equation based on horizontal. Now we will work out an equation based on vertical. And vertical, we can see we have two components that are pointing upward, which is A cos 30 and B cos 40, and both are upward, so we would add them up. The condition is an equilibrium, so the sum of these two would be equal to the weight of the particle, which is 25 Newton. So A cos 30 plus B cos 40 would be equal to 25, and then definitely work out the value of cos 30, which is 0.866, A cos 40, which is 0.766, B equal to 25, and that is equation 2. Our target is to find the values of A and B, and from equation 1 and 2 just place the value of A, which is 1.2855B, over here in this equation. So multiply this 0.866 with A, which is 1.2855B. So instead of this A, place this 1.2855B and just copy the remaining as same. 0.766B equal to 25. As we can see now, our equation is completely in the form of B. Just simplify it, get the value of B, which is 13.33. After getting the value of B, just place this value of B over here in this first equation, multiply it by 1.2855, and after multiplication we would get the answer for A, which is 17.1 Newton. And finally we have found the value of A and B Newton, which is the requirement of the question.